All right, let's talk about one of the most powerful and sometimes most tedious parts of programming, repetition. I mean, nobody wants to write the same line of code over and over again, right? It's a total nightmare. So today, we're going to crack open the essential toolkit for automating all those repetitive tasks in Java.
I mean, come on. You've totally been there, right? You need to print something 100 times, or go through every single item in a huge list, or, I don't know, draw a little pyramid of stars. Doing that by hand, it's not just boring, it's a massive waste of time. So what's the solution?
The answer, of course, is the loop. Think of it like your own personal robot, an automation engine built right into the language. It's just a simple structure that tells your program, hey, run this chunk of code again and again and again, so you don't have to. It'll just keep on chugging along until a condition you've set says, okay, that's enough, you can stop now.
And to really harness this power, Java doesn't just give you one tool, it gives you a whole toolkit. And just like in a real toolkit, each tool is specially designed for a very specific kind of job. So, what's in our toolkit today? Well, we've got four main players: the classic for loop, the flexible while loop, its cousin, the do while loop, and the super clean, super handy for each loop. Let's dive in and see what each one is good for. Okay, first up, we have the absolute workhorse of Java loops, the for loop. I call this one the counter, for a really simple reason. It's your best friend when you know exactly how many times you need to do something. So think about it. If you need a task to run precisely 5 times, or 1,000 times, or whatever specific number, the for loop is what you're going to reach for. It's just so compact, it's clear, and honestly, it's probably the most common loop you'll ever run into. Just take a look at this classic example. What we're really telling Java is this. Hey, start a counter, we'll call it I, at the number 1. Then, as long as I is 5 or less, run the code inside these curly braces. And oh yeah, after every single time you run it, just add 1 to I. And what's the result? Boom, it prints the numbers 1 through 5. So simple, but so powerful. So let's really break down what's happening in that one little line of code, because it's like a 4-step dance. Step 1, initialization. That happens just once, right at the very beginning. Step 2, check the condition. This happens before every single loop. If it's true, we move to step 3, execute the code. And finally, step 4, update the counter. Then it's right back to step 2, check, run, update, check, run, update, over and over until that condition is finally false. Okay, that's great. But what happens when you don't know the exact count? What if you need to keep doing something until, say, a user types the word quit? You can't use a counter for that. Well, for those situations, we need a different kind of tool. We need the guardian loops. And this is the while loop. Its logic is beautifully simple. It just says, while this condition is true, keep running the code. So in this example, as long as our variable I is less than or equal to 5, we keep going. Now you'll notice we have to handle the counting part ourselves inside the loop, but here's the really crucial part. The condition gets checked before the code ever runs. And that leads to a very important difference. And that difference is what separates the while loop from its close cousin, the do while loop. You see, since the while loop checks the condition first, there's a chance it might not run at all. If the condition is false from the start, the code inside is just skipped. But the do while loop, it flips the script. It runs the code first, and then it checks the condition. And that gives it this amazing superpower, a one-run guarantee. It will always run at least once, which is absolutely perfect for things like showing a user a menu and then asking if they want to do it again. Okay, so we've got counters, we've got conditions, but a lot of the time in programming, we just need to do something really simple. Go through every single item in a list or an array. For that kind of job, we bring in the specialist. I'm talking about the for each loop, which you might also hear called the enhanced for loop. Its whole reason for existing is to make your code way cleaner and a lot less error-prone when you're just trying to work with collections like arrays. If all you care about is grabbing each item one by one, this is absolutely the tool you want. And just look at how beautiful and clean the syntax is. You can literally read it out loud. For each integer, let's call it num, inside the numbers array, do this thing. That's it. There's no counter to set up, no condition to worry about, no incrementing. Java handles all that boring stuff behind the scenes. It just makes your code so much more readable and way harder to mess up. All right, so we've got the 4 main tools down. Now let's look at how we can really take full control and start fine-tuning our loops with a couple of more advanced tricks. Did you know you can put a loop inside of another loop? It's kind of like loopception. This is called a nested loop, and it's amazing for working with anything that looks like a grid or a matrix. Think spreadsheets or game boards. The easiest way to wrap your head around it is this. The outer loop controls the rows, and the inner loop controls the columns.
So, let's say we want to make a 3x3 square of stars. Here's how it works. The outer loop runs one time for the first row. Then, the inner loop takes over and runs 3 times, printing a star for each column in that row. Then, the outer loop runs a second time for the second row, and again, the inner loop prints 3 stars. You see the pattern? It's a really simple way to build out perfect grids.
But what if you need to get even more granular? What if you need to change the loop's behavior from the inside? That's where break and continue come into play. Break is your big red emergency stop button. The second the code hits break, it immediately ejects you from the loop, no questions asked. Continue is a little different. It's more like a skip button. It says, okay, I'm done with this particular run, just skip to the very next one.
Okay, we've covered a ton of ground here. So the big question is, how do you know which loop to pick? Let's boil it all down into a super simple guide to help you choose the right tool for the job.
All right, think of this chart as your ultimate cheat sheet. Is it a known fixed number of times? Use a for loop. Are you repeating something until a condition changes, but you're not sure when? That's a job for the while loop. Do you absolutely positively need the code to run at least once? Grab that do while loop. And if you're just strolling through an array or a list, the for each loop is your clean, elegant best friend. So let's do one final rapid-fire recap of our toolkit. For is for counting. While is your guardian, watching a condition. Do while gives you that one guaranteed run. For each is for gracefully walking through collections, and break and continue are your tools for precise control, the stop and skip buttons. You know, once you really master loops, you're not just writing code anymore. You're building smart, efficient automation machines. They are truly one of the absolute cornerstones of programming. So now that you have the power to automate just about anything, what are you going to build?